next in our computer math for data science, we're going to talk about logic. In logic, we need to talk about what we mean by a statement, and then the truth value for statements, and the compound statements, and logical operators, also called connectives, propositions, and truth tables, and logical equivalence, and algebra of propositions, and conditional statements. Okay, so this is Aristotle, who's often considered the founder or the father of logic. And he lived some more than 300 years BC. George Boole is a very important person in the development of computer science. We've been using the word Boolean, and that's named after him. Google celebrated his 200th birthday by changing their logo for the day. And, this is some of the kind of work that he did. He said about Aristotle, the great 19th century philosopher and mathematician and one of the founders of computer science, George Boole, said of Aristotle's theory of logic that it existed from ancient times, and basically it's continued to the present day for more than 2,000 years, and it's been basically the textbook for logic for all of that time. So the basic goal of logic, Aristotle's central observation, was that arguments were valid or not based on their logical structure and independent of the non-logical words involved. The most famous argument he discussed is known as the syllogism. So it says something like this: all men are mortal. Socrates is a man, and therefore Socrates is mortal. So this is a famous statement from Aristotle, and we call it a valid argument. And you can see that it's valid. It says all men are mortal. Socrates is a man, so he must be mortal. And the interesting thing about this is that you can replace Socrates with any other object and mortal with any other predicate, and the argument remains valid. So you can change these gray parts, but you still have a valid argument. For example, you could say all dogs have 4 legs, and then my puppy is a dog, therefore my puppy has 4 legs. Okay, so this argument is valid. May not be true. All the individual statements may not be true, but the argument itself, the shape of the argument, is valid. The validity of the argument is determined solely by the logical structure. The logical words all, is, the non-gray parts, are, and therefore are doing all the work. So this is what logic deals with, the subject of logic. It says whether an argument is valid or not. And many algorithms use logical expressions such as if P then Q, or if P1 and P2, then Q1 or Q2. So we need to sort of understand the structure of this kind of statement. It's necessary to know when these statements are true and when they're false. We'll refer to this as the truth value of the expression. And by when we mean, for example, if P is true and Q is false, is if P then Q true. So we'll talk about that. First of all, we want to make clear the meaning of the word statement. For example, consider this sentence. Consider this statement. The number I wrote down is greater than 100. So I wrote down a number, and I'm saying the number I wrote down is greater than 100. This is an example of a statement. So what do we mean by a statement in logic? In logic, statements are expressions that are either true or false, but not both. So this is either true or it's not true. It's not both. Okay? So therefore this is a statement. Any expression or sentence that is either true or false, but not both, is called a statement. Other examples of statements are ice floats in water. Okay, that's either true or it's not. 5 is greater than 6. That's either true or it's not. It's not true. 6 is greater than 5. It's either true or it's not. So these are called statements. Statements are things that are expressions or sentences that are either true or false, but not both. This, however, is not called a statement. So where are you going? That's not true, it's not false, it's just a question. Okay, this one we say has a truth value, and the truth value is false. This is not true. 5 is not greater than 6. Ice floats in water, that the truth value is true. So statements have truth values, but this doesn't have a truth value. Okay? In R, we might have something like x equals 8. That's not a statement, that's just an assignment. Now, in computer programming, the word statement might have other meanings. I'm talking about in terms of logic right now. But so we set x equal to 8, and then we say x is less than 9. So that is a statement in terms of logic. We'd call it a statement. And the truth value is that it's true. Since x is 8, 8 is less than 9, so the truth value is true. And if we type this first, and then we type this, and hit the return key, we will get true. So it does have a truth value, and it happens to be true. So this is a statement. X is less than 9 is a statement. It has a truth value, and it's either true or false, not both. Here's another example. Y is equal to 8. Y is equal to 10. Y is less than 9. Okay? This is also a statement, this one here, but in this case it's not true, and if you type this and then hit enter, you'll get false. Okay? So these statements, now as I said, the word statement can mean something entirely different in programming. I'm talking about it in the sense of logic. So statements are either true or false. Okay, let's make a data frame. So let's define a vector called age, and it has 19, 18, 20, 19, and 21. And let's suppose that we have a group of people, and we're measuring how much time they spend on some game, maybe per day. So this is 100, 120 minutes, 90 minutes, 110 minutes, and 100 minutes. Okay? And now we're going to use this command that we've used before called cbind or column bind. We're going to bind together these two columns into one variable. So we're going to bind them into game_user. So game_user is now going to have two columns. The first one is age, and the second one is time on game. So the first one is this, and the second one is this. So the assumption here is that person 1 is age 19, and they spend 100 minutes on the game. Person 2 is 18, and they spend 120 minutes on the game, and so on. And now let's make that into a data frame, because it's much easier to work with these things when they're data frames. So let's take game_user and put it in the as.data.frame, as data frame function, and that turns it into a data frame. Now next we're going to see a command that's very useful, but we haven't used before. This is the structure. It's asking for the structure of this object, game_user. Well, by the structure, one thing we mean is Is it a list? Is it a vector? What is it? And I just turned it into a data frame here, so it's a data frame. So when I type this command and hit return, it's going to say, oh, it's a data frame, and then it's going to give me more information about what's in it. So we already know what's in it. It's got age, which is a vector, and it's got time on game, which is another vector, and both of these are numeric vectors. They have numbers in them. So if I do structure and I hit return, it says that it's a data frame. It also gives us some more information about it. It says there are 5 observations of 2 variables. Now let's learn those words if we haven't done it already, or if we did it already, let's review them. Observations means 5 people, or 5 examples, and or if you like, 5 rows. So the first row contains the age of the first person and the time on the game for the first person. So 19 and 100 is the first row. The second row is 18, 120. So there are 5 rows, or 5 observations, and there are 2 variables. Two variables, age and time on game. So there are 2 variables. And then it says what these 2 variables are. Age, we already know, and time on game. And then it tells you that they're numeric, and it gives you some sample values. Now, in our case, there are only 5 values there, so sample values are all the values. But if we had 5,000 values in here, it would just give us, I think, 5 or 6 here. So just the first few, but just to give you the flavor of that particular variable. Okay, so now this is a very useful command. str means structure of an object. So you can use it on any variable to find out about that variable, but it's particularly useful when the variable represents a data frame. It tells you what's in the data frame, so age and time. Time on game. And then we can use another function which we've used already, view with a capital V, game user, and that gives us kind of a view of our data frame. So if we do that, it looks like this. So we have, as we said, we have the first column is here, age, and the second column is here, time on game. So the first row, as we said, has 19 and 100, 19 and 100, second row, third row, and so each row represents a student or person, so those are called the observations. Okay, let's stop this video and continue with a new video.